Are you there? Good morning, everybody. This is a juniors class, okay? As usual, we start with a very big smile. Smile, ear to ear. Everyone, I know I've come 5 minutes late. Sorry. Okay? Shall we start? Good morning. Yeah. Classes, I told you I intend to start a new chapter. Now, how many chapters have we finished so far? Good morning, all of you. Yes, yes, yes. I'm sorry to have kept you waiting. All right? Sorry. Yeah. Yeah. Good morning. Good morning. All the smiles and all. Very nice. Very nice. Yeah. See, class. I did four chapters up to now. I'll tell you what we did. First, we did transportation. All right. In transportation, I told you transportation is concerned with um, decisions of a manager outside the firm. All right. Now, outside the firm, what the manager has to do. For example, I gave you the example of Amul, and suppose Amul is in Anand, and it is in Anand, and Amul has to supply goods to all over the country, supply its goods all over the country. Suppose someone from Bangalore or someone from Mysore requests some goods. Ravi, good morning. Then what happens is Amul cannot send immediately from Anand. Anand is in Gujarat near Ahmedabad. Ahmedabad is when I last went in 2018. There was no direct flight from Bangalore. We had to fly to Mumbai. Well, I'm not sure. Maybe there was because I had gone on a Government of India work. It was mandatory to fly by Air India, and Air India, I think, did not have direct flight. I think probably Indigo has. I flew to Mumbai and then onwards. But Ahmedabad is a very well connected city, so there's no problem there. But the problem is the time factor. Suppose someone in Mysore says, "Oh, I forgot to tell you, there is something big coming up, and I require so many products immediately." Then Amul finds it. Maybe it's a big stockist in Mysore. So what happened? Mysore is 2 hours from 2.5 to 3 hours from Bangalore by road, 157 kilometers. So Amul cannot send immediately from Anand. Anand is 2 hours from Ahmedabad. From Ahmedabad to 7, good morning, to Mysore. So that is why Amul has already decided and kept certain warehouses, and the warehouses will be probably in Bangalore. Suppose Amul's warehouse is in Bangalore, say Mysore Tumkur Road, it will be very easy for Amul to send goods from Bangalore to Mysore immediately. So, given all these examples, I'm trying to tell you that it is necessary to do transportation modeling. In transportation modeling, in the first row, I showed you supply. There were suppose you are talking about supply from warehouses. The first column, not row, was supply. Supply had say warehouses 1, 2, 3 like that, and at the end of the row, say W1 was in first row. End of the row, you had the first column was sources. I'm sorry, class. The first column was sources, and the sources say warehouses 1, 2, 3. And suppose you had a W1, warehouse 1 on row 1. At the end of the row was the supply. The last column was named as supply. So in that column, how much warehouse 1 can supply of that particular product, how much warehouse 2 can supply, how much 3 can supply or 4 can supply. This was given to you. All right. Now we will come to the other this thing. Yeah, lot of you. So many of you. Dev, everybody. Rashid, good morning. Rupa, Anjali, Divya, Momoja, all of you. Good morning. If I've missed someone, sorry. All of you. My sweet students, good morning. So at the end of it, warehouse had supply given, and the supply was, yeah, it's really warm, and the supply was restricted to a certain amount. And then at the end of the problem, the last row was requirement, and in the requirement, it was given the second column was, for example, D1, D2, D3, D1, D2, D3, etc. were the retailers from to whom the warehouse had to go. All right, warehouse items had to go. So you had supply. Sorry, class. Yeah. Can you see me? Can you see me? Just give me, I don't know. Class, I'll just, if at all, I'll close up. Yeah, I'm live, I think. Hello? Can you see me? I don't know, something happened. I think by mistake I touched the pad. You can see me? Yes, yes. Thank you, thank you. I touched the laptop pad and I had a change of screen. So I was, yes, yes. Okay. So first, let's concentrate on transportation. In the transportation model, the first column was sources, and the next columns were D1, D2, D3, which meant the retail, and the last column was the supply. So in the first column, if there were sources at the end of the row, the sources, the constraint was the each source had a particular supply, and then at the last row, in the last row, you were given the requirement. So D1, D2, D3 had a particular requirement. Why do you think D1, D2, D3 have a particular requirement? If they require 100 toothpastes, for example, of 100 grams, why not give them 200, maybe in your mind? Okay, but there will be a constraint of, storing. So it may be possible that if you store more than 100 toothpaste, imagine 100 or 1 lakh toothpaste, 100 is a very small number, 1 lakh toothpaste, it may be possible that you may get nearly 20% spoiled because of the constraint of space, the way to keep, etc., etc. All right. With this, so the transportation issue that you had was that. The transportation issue you had was that you had 1 minute. I'm getting too many. Okay, the transportation issue you had was that there was a constraint of supply. There were a constraint on requirement, and in the matrix you had the numbers which showed you the cost that is incurred from source to the particular requirement, and you found out by different methods. The first method you did was northwest corner rule, and after that you did the column minima rule. In the northwest corner rule, you started with allotting on the upper left. Then you did the column minima rule, which whereby you started allotting the least in the column. Then we have the excuse me, row minima rule, whereby you started allotting on the least on the row. Then you had the least column method, and in the least column method, you started allotting the least cost in the entire matrix. Yeah, you remember? Then finally we did the Vogel's method. It is spelled as Vogel. In this, we allotted penalties. We allotted row penalties and we allotted column penalties. So after we allotted row penalties, how did we do the row penalties and column penalties? We took the least number and then we took the next least number, found the difference between these two numbers, and that was the penalty. After we did the row penalty and column penalty, we looked at the highest penalty. And in that, suppose in a row you had the highest penalty, we went into that row, and in that row we found the least cost and we started allotting. Then again we did the row penalty, column penalty, etc., and we did the allotting. And then after allotting, we found that after allotting everything, say W1 to D3, W2 to D2, something like that, everything once we allotted, we found how many allotments were there. Row plus column minus 1 is equal to number of allotments, means we can do the optimization test, optimality test. Okay, we could do the optimality test if the allotments were equal to row plus column minus 1. All right, then we'll go into optimality test. In the optimality test, we did U's and V's is equal to C. Each column, whether each cell, where there was a cost, we called it C. It was in the first row, everyone begin with C1, C like that. For example, the column in the first row, first column, the cell was C11. In the first row, second column, the cell was 1, 2, C12. So C12. See, when you say C1, 2, 1 stands for U, 2 stands for V. So obviously C12 is equal to U1 plus V2 is equal to C12. Do you understand? I will repeat. Suppose you have C23. C23 would be second row, third column. The cell C23 would be second row, third column. So C23 means the first number belongs to U, second number belongs to V. So you have C23 means U2 plus V3 is equal to C23. All right, so with that we had the numbers is equal to, we took the C's of the occupied cells was used to give you the transportation costs. All right, so what did you do with the transportation cost? If one allotment was done from W2 to C2, then W2 to C2, what was the cost in that column? C22, we gave it there and we found, and how many units were given there, how many units into the cost of the cell, cost given in the cell, gave you the cost at the end of the line, end of the row. So the total cost was calculated. To do the optimality test, we use the cells where allotment was not done, like non-occupied cells. With the non-occupied cells, we gave the equations and we took any one equation, usually U1 or U2, which appeared more than once in the equations. If it appeared in two equations, say suppose it was U1 plus V1 is equal to something, U1 plus V4 is equal to something, then we assumed U1 is equal to 0. After we assumed U1 is equal to 0, then we got V1 is equal to whatever was given at the end, and U1 plus V4 whatever, you got V4 is equal to what. With that, we found all the numbers, and then when we did the U and U plus V of each non-occupied cells, if we got any value less than 0, then we said the solution is not optimal. If we got 0 or anything positive, then we said the cell is optimal. The problem solution is this thing. Yeah. So one more thing. Yes, Rupa, I told you R plus C minus 1 is equal to Number of allotments means it is a non-degenerate problem. For a non-degenerate problem only, you do the optimality test. Now see, you don't have to, it is something that I have to teach you, that for a non-degenerate problem, an optimality test is possible. In the actual exam, I will never, sorry, the question paper will never give you a degenerate solution. All right, so that worry about should I do it for this, should I not do it in the exam, if I get less, say r plus c minus 1 is equal to 7, and I'm getting allotments only 6, should I do the optimality test or not? These kind of decisions will not be available to you. You will not be using those solutions in your question papers. Such a degenerate question will never be given to you. You will be given only a non-degenerate problem. Now, the question that you have asked, Rupa, for a degenerate problem, should I do an optimality test, will come when you go and go into your career. All right, that time no, it will, you can do, but the answer would not be the best. Okay, answer would not be the best. I wouldn't say ideal. Ideal cannot be achieved. It would be the optimal answer. So the in real life you cannot do, and if you do, the answer would not be the best. Is that clear? Okay. Understood, no? So I'm concluding transportation. Then we come to assignment. The assignment decisions are done inside the firm. So the assignment, you remember what we did? Again, we gave and we squared all the, whenever we allotted, we gave there a zero, and we found out how many zeros are there, and whether everyone can get, each machine can get one operator. All right, and vice versa, whatever it is. So when we got each operator got one machine, etc., we did the assignment and we worked out. Suppose we did not get the proper, we could not do the allotment, then what we did, we joined all the zeros. To join the zeros, we saw in each row whether there was more than one zero. Wherever there was more than one zero, maybe two, maybe three, or maybe only two, we drew a line. And then we looked at the columns, and each column, wherever there was more than one zero, we drew a line there to join the zeros. Then, if there was any other zero left, we randomly drew one line. But then when you draw a line like that, please see whether the costs are lower in the row or column. It is better, to see like that, and then draw the line. So once we joined all the zeros, what we had to do three things. First what we did is one minute. Yeah, we had to do three things. The first thing is, in the non-occupied cells, you have to see. One minute. Okay. In the non-occupied cells, you had to see whether there was the least number. So suppose let's say the least number for us was 4. Okay. In the non-occupied, or the cells were not untouched cells, whether there was a number 4. Untouched cells means wherever these lines did not, to joining the zeros, did not go. So we took that, and we found that, suppose we found in the untouched cells, you had the least number was number 4. So we took this number, and what we did with this number, wherever the lines were intersecting, that was called the intersecting number. To that number, we added the least number. In our case here, it was 4. Suppose that intersecting number was 0, we added 4 to 0, and we made it 4. Wherever the line crossed some numbers, if suppose in the second row, the line, we had drawn a line on the second row, all the numbers of second row except the intersecting number were left untouched. Wherever the numbers were there, where no line was gone. So suppose there was an untouched number 8, then from 8 we minused 4. 4 was our least untouched number, we minused. So with this we got a new matrix, we did allotment and so on and so forth. Alright. Then we did, what else did we do? Okay. What else did we do? We did network modeling, a very big chapter, which was beautiful. Network, we did critical path method. Now, first we did we had activity and we had events. In the activity, we had 1 is to 2, 1 to 3, etc. So 1 is an event, 2 is an event, 3 is an event, etc. We call them events. So we had duration given. So we drew like how we do the decision tree. We did the network modeling and we got the network model. After that, we started allotting the duration. First, we drew the, yeah, happy morning to you too. A very happy morning to all of you. All right. So what we did is we drew the network model. After we do the network model, we added the duration. We cut the event. Event was a big circle. We cut the event, and on the right hand side, your right hand side, we started giving the beginning event. Okay, we started giving the beginning event. So we started adding and we went to forward pass, meaning from 1 to 3, meaning ascending. From 1 we went to the last event, and in the forward pass, the bottom numbers, whatever the time, we always took the largest one. Why? The reason for this is, in practical life, suppose 1 to 2 takes only 10 minutes and 1 to 3 takes say 12 minutes, and then 2 to goes to 4, 3 goes to 4. So unless you complete 2 and 3, you cannot go to 4. So 1 to 2, understand, 1 to 2 is 10 minutes. 1 to 3 is 12 minutes. So 2 goes to 4, 3 goes to 4. These are preceding events. 2 and 3 are preceding events. So if 1 to 2 is 10 minutes and 1 to 3 is 12 minutes and 2 to 3 and 2 to, let us for 2 to 4, 3 to 4. So 4 cannot be, let us for this thing, cannot be done or cannot happen unless 2 and 3 happen. So even if 2 happens in 10 minutes and then whatever the time between 2 and 4, unless you complete 3, you cannot go to 4. So this is the reasoning why in forward pass, okay, Dave. So in forward pass, we always took the larger number, meaning to one circle, one event, if there were more than one arrows joining, more than one branches joining, then what we did is, we in forward pass, we always took the larger number. So we did, and we went and found the highest amount of time that we took to reach the last event is the project completion time. Remember, we always took the larger number for every event which had more than one branch. So finally, when we went to the last one, we automatically got the largest project time, longest project time, sorry, the largest time or the longest project time. So this time was called the project completion date. Then we worked backwards. As we worked backwards, we always took the least time. In forward pass, the highest time, when there was a decision between two, if one event had more than one branch coming to it, it was a decision to be taken between each decision to be taken. So that was for in forward pass, higher number. When coming back, in rolling back, like remember, we roll back like a mat. In as we do in decision tree, we roll a mat, no, like that we come back. When we come back, we take the least number. So when we took the least number, we looked for the critical path. The critical path was given to us whenever the beginning number and the ending number was the same. So we found the critical path maybe we went to 1 to 2, 2 to 4, 4 to 6, something like that. We got the critical path. Now, after we got the critical path, we started doing more problems in that. The first thing we did was the slack. Slack means how much time you can afford to waste without harming the beginning of the next subsequent event. Alright, the total float was how much time you can waste to complete the entire project time, whereas the free float was how much time you can afford to waste before reaching the next event. Is that clear? Then the independent flow is independent slack. You say no, cut that person some slack, man. Means give him some, take it with a pinch of salt. Whatever he or she says or claims may not be 100% true. So cut him or cut her some slack. We say no. That's the same word. SLACK. Float is FLOAT. Do you understand? Float and slack. All right. Now here we are. Um, Yes, we finished that, and then we went on to other things in one more issue in the network modeling, whereby I gave you OMP. Remember the for whatever wherever remember this OMP. Okay, O stands for optimistic time, M for most likely time, P for pessimistic time. Is that clear? OMP. All right now, what happens is if you make OMP, when you get the optimistic most likely time and pessimistic time, there's one thing that you won't get, the duration. So when the problem comes with OMP, I told you always arrange it in OMP way. Alright, arrange it the rows or columns in OMP. Let the O come as the first row or the first column. I would say row is better, and then M and then P. Is that clear? I have, droplets of sweat running in my hair. So it's a really warm summer in Bangalore, isn't it? Yeah, but it's good to sweat, class. Keeps you more active and healthy. Okay, here we are. I was talking to you about in the thing of OMP. So what we did, hi Hassan. The second row was to calculate the duration, but here I told you do not use D for the duration because D has one is used as a notation for one more formula. So what you do is you have the second column as T to the base E. You have to remember as O plus 4M plus P divided by 6. E is equal to, forget the T's. E is equal to O plus 4M plus P divided by 6. If you write it in OMP way, it becomes simple. Alright, then we go to the last column, that is in that P minus O the whole by 6 the whole squared. Alright, the number value at P minus O, that is pessimistic time minus optimistic time divided by 6 the whole square. This is the variance and we kept it there. We got the duration in the second column and we went ahead and we did the network model. After we did the network model, we calculated the project time, project completion time. Then we found out the critical path. After we found out the critical path, we had to do one issue. What happens? Suppose your project time was 30 days. So there were two issues. They asked you what is the probability that the project will be completed after 30 or less than 30. Okay, when it was given as after 30, let's say the project example I'm taking now, you completed in 30 days. So how to calculate? There was a value saying some a minus b by root something. A was the expectation, b was the project time. All right. Suppose they say, what is the probability that this one, which this project which completed in 30 days was completed in 34 days? So you did 34 minus 30 divided by root over what? You did the sum of the variances. Which variances? The variances of the activities which were involved in the critical path. Suppose you got 1 to 2, 2 to 3, and 3 to 5. Please remember 1 to 2, 2 to 3, 3 to 5. So the events that you looked for was 1 to 2, 2 to 3, and 3 to 5. And based on these events, they were in the first column. Go to the end of the column for variance. Add the variance of the activities where the CP is there. All right, that is root over what? The total of the variance of the critical path method, critical path. Is that clear? So we did that and we got. Now suppose we got a number for finding the probability which is greater than the project completion time. Then we added zero point 0.5 to it in the area. All right, we took the table value, and for the table value in the normal distribution curve, we added zero point 0.5 to it. All right. On the other hand, if in our problem we had 30, right? So if they asked what is the probability that the project will be completed in 25 days, then we took that table value and 0.5 minus that, we minus that number, and we got the value. Is that clear? So there is no probability, you do not get a negative. You always have just write just a number. All right. So with this we completed. Yes, I've completed telling you how many chapters. Pro- Transportation, assignment, and then network modeling. Yes, anything else? I think we did sequencing, isn't it? In sequencing, we gave, suppose, please remember one thing. Suppose they say start allotting, if they don't say anything, start allotting. Now I'm talking about sequencing. Machines and how to allot what machine to which job. So suppose they do not tell you the sequence, you start allotting the least amount of time. Start allotting from the least amount of time. Suppose they tell you go as BA, then you start with machine B, then A. When you have more than two machines, then what do you think? Yes, Kiran, good morning. When you have more than two machines, then what do you do? Suppose you have machine A, B, and C. A plus B becomes G, then B plus C becomes H. All right. There's sometimes the sequencing is given, how to allot. If the sequencing is not given, what do? We start with the smallest time allotted. That I think was pretty simple. Yeah, that I think was pretty simple. Okay, so so that. Okay, now today we are going into replacement models. Write down everybody, replacement models. All right. Okay. In replacement models, it is similar to what we do a depreciation problem. And replacement models are useful for two things. See, normally when you buy a machine, you know what is the value of the machine, what is the value of the installment, not installment, sorry, installing the machine, So after that, what we do is we find out the, we find out the depreciation per year. There are direct methods, all different types of methods you have learnt. Now we know when we need to replace the machine. All right. So it may be like, see, we in depreciation we do not say when we have to replace the machine. We only calculate the book value of the machine for any number of years. Remember class, in depreciation, the decision of replacement does not come. We have, say, in 10% every year in the direct method. We'll look for the direct method. If the machine was 1 lakh, it becomes 10% less, 90,000. 10% less, 9,000, 81,000. Again, 72,000, whatever. Okay, it goes on like that. But we do not take a decision of when to replace a machine. We only do the calculate the book value of the machine according to the depreciation. Is that clear? Here we do decisions on when to replace the machine. See, we are going to do a column and I'll tell you, C is the capital cost, what is the scrap value, etc. etc. All we calculate and we get a last column. Before the last column, we get one column called saying total cost. Is that clear? And the last column is total cost divided by the year. So there's a total cost, and if it is in the third year, divide by 3. That last column is called average cost. So we do average cost for the number of years the data is given in the problem, and then we look for the least number in the last column, that is average cost. All right, please listen. We look for the smallest value in the average cost column, which is the last column that you have to do. So the decision to replace the machine will depend on this smallest value in the last column. Suppose in the year 5, you find the smallest value of average cost. You say at the end of year 5, it is prudent to replace the machine. Is that clear? At the end of, suppose in the last column, average cost column, you get the smallest value or the smallest number in year 5. Your decision to your management would be, according to my calculation, all right, the other things have to be correct. According to my calculation, at the end of year 5, please replace the machine. Now, this is a proactive method, a purely pre-calculated way of replacing the machine. All right. The other way would be breakdown. If the machine breaks down, then how are you going to replace? So these are the two issues we are going to do. I will start. It's already 10, almost 10:30. The problem is pretty small and very easy. Get ready. I'll dictate the problem. Please write. Yesterday, I saw the number of views of my video for Amazon case study. It had crossed 160. I'm happy, class. Keep logging in. All right. See, from Monday, we are going according to the timetable. Tomorrow, some of you have something at home. So tomorrow is a Sunday. I will not take class. But whenever I get a good case study, I will let you know. I will come online. I'm thinking I'll come online earlier than everybody else, and I'll do the case study. If you can log on at that particular time, log on. If you cannot, take the link and see it later, because these case studies are very, very important. I unfortunately, in the class when I teach you, I haven't been doing many case studies, or I've been doing lots of case studies. I do case studies in my every class, but I do caselets, small examples. Here I'm doing a full 1 hour case study. All right. So you will understand with my case studies I collected from all over the internet and I never take it from books. I take it from real life events. All right. I build up a case study from real life events I gather from various websites, the Hindu, the Times, the CNN, the BBC. And sometimes I'm very grateful to some people who are authors and give an example. I found some very valuable hints on Toyota from one author who said he knew senior employees retired employees from Toyota. Yes, Sunday I will not take class. I don't think anyone else is taking, but I don't know about next Sunday. This Sunday, though, I can guarantee you, we'll work one day at a time. Tomorrow there will be no class. I don't think I am coming for taking class. No one else. All right. Whenever I feel there's a very good case study, see, I want to give you Amul case study. I tried to. I have a friend there because I went to Amul and had personally met all of them. So I have a friend there. She hasn't responded. So I'll ask her if there is any. Why I'm asking her is I want to know the latest information on Amul, but it is available on the net. I will search. But I would like you to log on for Amul case study. I'll tell you when I'm going to do. I will after class or everything, or before class, I may do the case study. All right, I'll tell you. All right, but certainly not tomorrow. I need time to do good, groundwork before I present you the case study. I know it in my mind, but I want with statistics. All right, which I do not cannot remember. So we start already. The problem start. A firm is considering a firm is considering the replacement of, I repeat, a firm is considering the replacement of a machine whose cost price is rupees 12,200, whose cost price is rupees 12,200, and scrap value is rupees 200. Scrap value is rupees 200. Based on the maintenance cost, based on the maintenance cost given below, repeat, based on the maintenance cost given below, decide when should the machine be replaced. Decide when should the machine be replaced. I will repeat the entire sentence. See, I do not take straight from the book. By the way, I want to acknowledge Mr. Vasuki, who's a senior faculty in Bangalore Institute of Management Studies. He has written this book and he presented this book to me. Two copies. One is in the office, one was at home for emergency. And thanks to that book, which was at home, I'm able to do your classes because we need and this book is very simple, so it is useful to understand. And then the more complicated or difficult problems, if any, I will do every day in revision. Currently, let me finish the portion. All right, acknowledgement to Mr. Vasuki. All right, ready? Now you have to have 9 columns. All right, 9 columns, small ones. It is only I'm giving you the problem in a row wise. All right, because it's actually 2 columns. I don't want you to waste the space. So, and I also want you to copy the entire problem and do it again. So, write down in a row. The first row heading is year. As I told you, 9 columns. So the remaining columns are numbered as 1, 2, 3, 4, 5, 6, 7, 8. I repeat, the first column, first row heading is year. And in the row you write 1, 2, 3, 4, 5, 6, 7, 8. The second row is called maintenance cost. See, whenever I say cost, you have to write in brackets rupees, whether I say it or not, because you have to have some units for your answer. All right, ready? Maintenance cost. Now, under year 1, you write 200. Next is 500. Next 800. 1200 or 1200. 1800 or 1800. 2500 or 2500. Next 3200 or 3200. Next 4000. I will repeat, class. You have 8 years. The rows are, the first row heading is year, second row heading is maintenance cost, and you have 8 years, and the numbers of maintenance cost is like this: 200, 500, 800, 1200, 1800, 2500, 3200, 4000. So your decision will be to have the machine replaced. Now class 1, 2, 3, 4, 5, 6, 7. You have to draw 7 columns. You have to draw 7 columns, all of you. And the first column is very thin, okay, because it is year. All of you, the first column will be called year and call it small n. I'll show you here. In brackets you put small n. Can you see? Year and small n. How many years were there? 8. So make, 1, 2, 3, 4, 5, 6. Totally I told you 7 columns. Let me give you the headings of second all the columns. The second column is called maintenance cost. In rupees. The third column is total maintenance cost. This is the cumulative of the previous column. Okay. So you write total. I'll call it total MC. Okay. Now summation of, I'll put 2. Wait, I'll show you. What I've done is 2 is, see, can you see? 2 is the maintenance cost. 2 means column 2. Total MC means total maintenance cost. I did summation of the second one. It is a cumulative. Alright. I'm just, a summation of 2 may not be the correct way to say it, but I just want you to understand. Next column. The column number 3, column number 4 would be S of T. Just say S of T. That is, what was that, 200? Scrap value is 200, isn't it? So this is scrap value. Scrap value, I'm writing it as S of T. Later on, we will write it in a different way. Let me devise a simpler way, but currently you write S of T. Next column is C minus S of T. Capital C minus S of T. I'll tell you what is C. C minus S of T. C is 12,200. That is capital cost of the machine. Now we come to total cost. Total cost, that is, write down TC is equal to column 2 plus column 4. Here, it's not column 4, wait. 1, 2, 3, 4, 5. So it is, write the columns class 2, 3, 4, 5. Here it is 3 plus 5. That is maintenance cost and the last one. You have to add maintenance cost plus C minus, or yeah. So you have to add 3 plus 5. Column 6 is equal to, I repeat, column 6 will be total cost is equal to 6, that is column 6 is 3 plus 5. Last column is average cost, AC. As I already told you, it is TC by N, that is the years. I will explain again. Please look at this. The first column is year, I have called it N. The first column is year, I have called it N. You can see. Next column, number 2 column is, this is the first column. I'll make it column 1. Column 1 class, we'll do it carefully. Can you see? Column 1 is year. Column 2 is maintenance cost. Okay? Column 3 is summation of column 2. That is total maintenance cost. Column 4 is salvage. Whatever you get, no salvage. So you just put it as S of T. Column 5 is capital C minus S of T. C is the cost of the machine, 12,200. How come 7, 8 years? It is the same value. Next is total cost. Total cost is column 6, that is 3 plus 5. That is maintenance cost. Total maintenance cost plus C minus S of T, 3 plus 5. Last is the previous column, TC by N, or column 7 is equal to 6 by N. It is column 6 by N, not number 6. Alright? Not number 6, column 6 by N. Now we will do one by one. First, you rule the rows and 8 rows. One in the column 1 under here 1, 2, 3, 4, 5, 6, 7, 8. Please rule. Once upon a time, we used to write letters to family, to friends. So we used to have lot of white sheets at home, or any sheets. Letterhead. I remember my father used to give us letterheads because my father was a sailor, and once a month all of us wrote him a letter. All of us, 7 children, wrote him a letter. So mommy used to give us letterheads. Daddy had brought pads, letter pads, and each one of us was given one paper, or if you want 2 sheets, whatever, to write to your father. My father used to call him Bab. So Baba would be very upset if all of his children, sweet like me, did not write him a letter. I told you I miss my father. April 16th, 2 days ago, was his death anniversary. So we had a lot of white sheets at home. These days we type. So if we have the laptop at home, why do we need white sheets? So I have one more issue. I found out some white sheets that my husband kept, and I'm using them. If those finish, I'll have to. I have some small notebooks. I'll have to start using them. I don't have notebooks at home like you children, no? Ready? Now we start. Everybody, you look at the maintenance cost. Maintenance cost, you have to fill it in column 2. So I'm filling column 2. Column 2, I'm filling. Write down 200, 500, 800, 1200, 1800, 2500, 3200, 4000. Everybody? Now column 1 is here. It is also called N. Column 2 is maintenance cost. Now the third one, look at the column 3. Column 3 is summation of column 2. So how do you do it? Look at the column 3. I'm going to fill it like this. The first cell will be 200. Next, 200 plus 500, 700. Followed by 700 plus 800, 1500, like that. So write down in column 3, 200, then 700, then 1500, 2700, 4500, cumulative of the previous column. Remember, ouch, 7000, I think it is 10,200 and 14,200. It's an easy problem. Look at it. Cumulative of the previous one. Now, S of t, that is the salvage cost, is given. They say 200. So every year you have to add 200. I also cannot figure out how salvage cost is every year 200, or the salvage cost is there, isn't it? It is to be used every year because you have to calculate. See, you're going to find out which year is the least number. So naturally, the salvage cost has to be taken care. That is why we have to use the salvage cost every year. It's not that we are using it to minus it from depreciation. No, it's only that salvage cost has to be minus from that year's, whatever economics you do, value you do, because you have to find the right answer. All right. Even if you don't put the salvage cost, if it is same, it doesn't matter. But we have to do to get the smallest number. It doesn't mean that we are using the salvage cost every year. We are using it only to adjust that value of that year. Okay. So put 200 every year. 8 times you write 200. There is a tree outside my house and this shade. So all the vegetable hawkers will stand under that tree and scream. So what you're hearing is vegetable hawkers selling tomatoes, 5 kgs. 5 kgs is 50 rupees. I feel sorry for the tomato growers. Imagine you grow and sell them for 10 rupees per tomato kg. How much must they be selling at? 1 rupee? What do they eat? And it is all physical labor. The class always have compassion and consideration for the vegetable grower or the farmer in our country. They work so very hard, really hard they work. right? So my table goes like this. Don't be worried, I'm finishing soon. I know you have another class and okay. Next is C was 12,200. Correct class? The cost of the machine was 12,200. So if you do the fifth one is C minus 4, column 4. Column 5 is equal to C minus column 4. C minus column 4. Okay. So C was 12,200. Column 4 is 200. So the entire column 8 times you will get 12,000. 8 times 8 times you get 12,000. Why is Manjunath calling me during class? Manjunath, you write here. I cannot talk to you during class. Section A, Manjunath, the engineer fellow who said he's done engineering in medical supplies. Ask him to, write here. Especially when I'm doing a table, I cannot be distracted. Okay. So next one it is t is equal to 3 plus 5. So 3 is 200 plus 12,000. 12,200. Next is 12,700. Next it is 13,500. Next 14,700. 16,500. 19,000. 22,200 and 26,200. Column 3 plus 5. I am holding this for all of you to see. You can see, can't you? Now class AC, the last one we will do. If you go ahead and do class, this column divided by column 6 by n, meaning 12,200 divided by 1, 12,700 divided by 2, here 13,500 divided by 3, 14,700 divided by 4, etc. Go on. Now the first one will be 12,200. Next one I think will be 6,350. What is the third one? 4,500. Next one I think is 3,675. So 16,500 divided by 5 is 3,500. No, 3,300. Next 19,000 by 6 gives you I think 3166.67. Next I think around 3,171.42. Last is 3,275. No problem, Manjunath. I'll talk to you after this class, okay? Whatever you have to say. Accept your apologies. Now everybody, I'll keep this table like this. If you have missed, you see, which is the least number in the last column, it is 3166.75. So at the end of sixth year, your advice to your management would be, at the end of sixth year, you give the replacement of the machine. It is 10:55. I'll stop now, but I'll show this table for a minute so that all of you can copy. If anyone has not finished, take a picture of the screen. I'll hold it without. Wait once again. If anyone is this thing, take a picture of the screen. And your decision would be that write down last, the machine should be replaced at the end of the sixth year. Why at the end of the sixth year? Because we always do all our calculation at the end of the year. We buy at the beginning of the year, etc., and we dispose at the end of the year. Everyone got it? So please look at it again. The first column is for the year. The second one is the maintenance cost that is given clearly in the problem. Column 2 is maintenance cost. Column 3 is cumulative of the previous column. 200 plus 500 gave 7, 700 plus 800 gave 1500, etc. The next column was salvage cost. The salvage cost comes only once, but suppose we sell it in each year, then the salvage cost has to be considered because we are considering the value of the machine average cost for every year. That is why. The next column was C. C was capital cost, that was 12,200 of the machine, minus the salvage cost, that was 12,200 divided by 2 minus 200, 12,000. And of course we don't use it for every year, but in this case, as I told you, we want the actual average cost for the year, so we are writing it like this. Next is total cost, that is 3 plus column 5, that is maintenance cost plus capital cost minus salvage. So here you'll get 12,000 plus 200, etc., etc. So your total cost is there in column 6. Column 6 is equal to 3 plus 5. Then last value is average cost. This is every total cost divided by the year. In the first year, year 1, total cost was 12,200. So 12,200 divided by 1. In the second year, the total cost was 12,700. So 12,700 divided by 2. In the third year, the TC is 13,500. Since it is in the third year, 13,500 divided by 3 is equal to 4,500. Fourth year, 14,700 divided by 4 is equal to 3,675. In the fifth year, 16,500 divided by 5, 3,300. Sixth year, 19,000 divided by 6, 3,166.67. Seventh year, 22,200 by 7, 3,171.42. Eighth year, 26,200 divided by 8, 3,275. Now look in the last column. 3,166.67 is the smallest value. So that happens in year 6. So if any of you want to take a picture, please take a picture. I'm holding it without moving. So what happens is, in the sixth year, since the average cost is the least, your advice to your management or to yourself, if you are the manager in charge, to change the machine. This is, please remember, this is for individual replacement of a machine. Individual replacement of or replacement of an individual machine. This is the right way to say it. Or as the book says, individual replacement. Is that clear? Everybody understood? I think I have to stop here. I have started chapter 5. I think I have gone about 60 to 70%, 65% of the portion is already over. So I can feel the smiles on your faces. Yes, we have done great work since I've been teaching you every day. We have done really good work thanks to your cooperation. Class, I don't mind whether what time you see my video. I have no problem, but you have to see my video. I was extremely happy to see 165 or something views. But please remember, you are 151 in your junior class A section and B section together, and seniors are 79. How much does that make it? 160. 151 plus 9 is 160. 160 plus 70, 230. So where are the others? Sleeping? Yeah? Yeah, I know. Divya coming up. Others are sleeping. Never mind if you sleep, wake up. It's time to wake up and learn. Yesterday was a case study, but I'm telling you, I take a lot of effort to bring you material, and not old material, recent material from all over, wherever I can find. Okay? So take care, class. I'll see you on Monday. I'll come sharp 9:30. Today I had a little some disturbance. All right? I promise you 9:30 sharp. We will continue with replacement issues. Yeah, you have to smile. I'm not going to sing you a song today. Yes? Be happy, be bold, be strong. Yeah? When the going gets tough, the tough get going. And all my students are very tough. Eat well, drink healthy, eat healthy. Drink well means drink lot of water. Now that it is summer, drink lot of water. That is what I mean by drink well. Okay, don't make faces. Rupa, yes. I don't, oh my goodness, Rashid. Yeah, yeah, your smile, very good. Keep the spirit up. Yeah, yeah, Vicky, yes. You know what I'm going to say. Yeah, I'll stop the class now. Yes, keep smiling, take care of each other, you know, and if someone is in trouble, someone is distracted or restless, talk to each other. As I told you, you keep your social distancing, but then you keep your, contacts also. Don't ever fight with each other. Small things. We get angry with each other. Yes. But if you just count from 10 to 1, 10, 9, 8, if you are the angry type, start from 20, 19. If you are the too angry type, start from 100, 100, 99, 98. Check your capacity. By the time you check your capacity and say 4, 3, 2, 1, all your anger will go. Please remember, we can get angry, but anger clouds your judgment. All right? We write something, we talk something when we get angry. All right? Try to control your anger and don't say anything when you get angry. Okay? Because what comes from the mouth cannot be put back. Right? It cannot be put back. Your vomit cannot be put back. An angry word is as lousy as the vomit. You understand? Can you take your vomit and put back? You'll say. Right? Yeah. Your words in anger are as bad as that. So when you're angry, okay, when you're coming down, 100, 99, 98, 97, 96, 95. I'm pretty good, huh? So you can imagine how angry I used to be. Okay? Bye, class. Love you all. Take care. I know you have other classes. From Monday, you'll have regular classes. So spruce yourselves up, whatever you have to. Divya. Okay. Huh? Okay. Okay. Never mind. You can say Jai to your country. Yes. Lovely. Okay. Bye, class. Take care. Keep smiling. Broad smile, ear to ear. I got lovely smiles. Yeah. I can see that you have understood. Okay. Jai Hind. Jai Karnataka.